Alrighty, guys, let's go ahead and take a look at this question. It says, an arrow is fired, giving it a velocity of 44 meters per second at an angle of 46 degrees from the horizontal. The arrow flies through the air narrowly, missing a bird, oh man, and lands on the ground some distance away. So here is my arrow. It's going to fly through the air, and then it's going to land back at the ground. Wants us to figure out what the x and y components of the arrow's initial velocity are. How far does that arrow finally land? What's the maximum height? The total speed at the apex? How long was it in the air? And then the total final speed. Okay. So let's start by drawing a picture. I kind of drew one up above, but I'm going to draw another one here. So here's my arrow. It's being launched at a 46-degree angle, and the velocity that's being launched at is 44 meters per second. So once I have that drawn out, I can go ahead and draw my x velocity, which would be right here, vx. And then I can add the y velocity, which is going to be right here, vy. It says it lands at the same height that it was shot at. So it should end somewhere over here at the same height. And it should end just like this. Here's my horizontal. So then I got to draw my x velocity as well, where it ends, which is over here, and my y velocity, where it ends. And then some angle again. We'll talk about that angle and all that stuff at the end. So to start off, it wants us to figure out Vx. Well, if we look at this triangle, we have the hypotenuse, and then we're missing the adjacent and the opposite. So the x is the adjacent, so we are going to need an equation that involves adjacent, hypotenuse, and our angle. Therefore, we're just going to use cosine. So Vox is what we're solving for now, the initial velocity in the x. So if I take my equation, I get cosine of my angle, which is 44 degrees, is equal to the adjacent, which I don't know, which is Vx, over the hypotenuse, which is 44. To solve for that, I'm going to go ahead and multiply 44 over to the other side. So I end up with 44 times cosine of 46. My mistake. I wrote 44 for the angle there. So this angle should be 46. Sorry. All right. And that's equal to Vx. Plug that into my calculator, and I find out that Vx should equal 30.57. So Vx is now solved for. You can go ahead and write that up here, 30.57. All right, next I'm going to solve for Vy. Well, Vy is the opposite side, and I have the hypotenuse, and I know the angle. So I can go ahead and use sine. I also could just use Pythagorean theorem, but I'm going to stick with the angle just in case I made a mistake calculating Vox, which I almost did. It's good to just stick with the trig function and solve for the opposite side using sine. So Voy, I have sine of my angle, which is 46 degrees, is equal to Vy over the hypotenuse, which is 44. Multiply that 44 over, just like I did before, because I got to get Vy by itself. I end up with 44 times sine of 46, and that is equal to Vy. Plug that into my calculator, and I find out that Vy should be equal to 31.65. 31.65. Okay, so now I got VO, I got Vx, I'm all good to go. I need to start solving for how far these things land, the maximum height, so on and so forth. So I've done all I can do without building my kinematic table, so I'm going to go ahead and do that down below. I know that I have x and I have y. I have dO, dF, VO, VF, A, and T. Okay, so quickly just write this table out. All right. In the x, the VO was 30.57, so I'm going to write that right here. The initial distance is 0 because it's starting at the origin. But if we know the initial velocity, we also know the final velocity. And the reason we know that is because the acceleration in the x is 0. Therefore, the initial and final velocities are the same. For the y direction, the initial distance is 0. Well, let's see the question that I'm solving for. This question is how far did it land? So I'm solving for the final distance, which would mean that the final distance in the y is also 0 because it's the total distance that it's covered. It starts at the ground and it ends at the ground. So the initial velocity in the y is 31.65. The final velocity, well, it's coming back down. So the final velocity is negative 31.65. We know this because of symmetry. And acceleration in the y direction is because of gravity, so it's just negative 9.8. So now we can go ahead and solve for df in the x direction. But before we do that, we need to know time. In order to solve for time, we got to do that in the y. So let's go ahead and use little pup. Little pup is vf equals vo plus a times t. So vf in the y is negative 31.65. VO is 31.65, A is negative 9.8, and T is unknown. Got to get that by itself, so we're going to subtract 31.65 over the other side and then divide by negative 9.8. So I'll go ahead and simplify this just a little bit for us so we can see exactly what I'm doing here. So negative 31.65 minus 31.65 is going to give me negative 63.3, and that equals negative 9.8 times t. Get t by itself, divide by negative 9.8. Doing so, I find out that t should be equal to 6.46. So our time is 6.46 seconds. Okay. Now that I have the time, I can go ahead and solve for distance final in the x. I know that df in the x is equal to do plus vot plus 1/2 at squared. All of this is in the x, and because it's in the x, acceleration is 0, initial distance is 0. So df is really just equal to vo, which is 30.57, times our time, which is 6.46. Multiply those two things together, and you find out that the final distance should be 197.43. So let's add that up here. 197.43. Next question says, what is the maximum height reached by the arrow? So in order to figure that out, we're actually going to need another column here. And maximum height occurs at the apex. So at the apex, the initial distance was still launched at the ground, but we don't know the final distance. The initial velocity in the y is still 31.65. The final velocity, however, is 0 because it's no longer moving at the apex. Acceleration is still negative 9.8, and the time at the apex is actually half the total time. So instead of 6.46, our time to get to the apex is only 3.23 seconds. Now that we have all these variables written out again, we can go ahead and solve for the distance that our object reaches in maximum height. We're going to use the exact same equation, but this time we've got to plug in our y variables. So df equals do plus vot plus 1/2 at squared. df is what we're solving for. do is 0. vo is 31.65. Time is 3.23 because it's the apex time. So we got to multiply these guys together. Plus 1/2 times my acceleration, which is negative 9.8, times my time, which is 3.23 squared. All we do is plug this into our calculator, go ahead and get our answer, which is 51.11 meters. So the maximum height reached by the arrow is 51.11 meters. Next question says, what is the total speed of the arrow at the height or at its highest point? Well, at its highest point, it only has horizontal velocity. So the total speed is just our x velocity. So it should just be Vx. What is Vx? Well, Vx is 30.57. And Vx doesn't change because there's no acceleration in the x direction. How long was the arrow in the air for? We already solved for that down below. The total time the arrow was in the air was 6.46 seconds. And then our last question, what is the total velocity of the arrow when it hits the ground? Well, if it's shot up at 44 meters per second at a 46-degree angle, it's going to come back down with the opposite numbers. 44 is the velocity. It's just our size. So the size is not going to change. So it's still 44. But what is going to change is the direction. Instead of positive 46, when it comes down, it's going to be negative 46. And that about wraps this question up.